They say that comets are messengers from deep time, fragments of ice and rock that carry with them the memory of other worlds. Normally, when a new one is discovered, astronomers know what to expect: a faint body that slowly ignites as it approaches the sun, displaying tails of gas and dust that behave in familiar ways. But this time, the story took an unexpected turn. In July of 2025, the telescopes of the Atlas tracking system in Chile detected a peculiar object. It was an interstellar visitor. That is, a body that does not belong to our solar system, but arrived from remote regions of the galaxy. They named it with a name as strange as its origin: 3I Atlas. At first, the predictions were simple. The orbital calculations showed that it would follow a hyperbolic trajectory, which means it would only pass through once, with no possibility of returning. It would be, then, a brief flash in the history of the sky. And yet, just a few weeks later, something began to trouble the observers. The comet, instead of remaining faint, began to shine brighter than expected. Its magnitude records, which indicate apparent brightness, showed an increase that did not fit the models. And along with that increase, in even more bewildering detail, the comet seemed to be turning green. Green in comets is not entirely rare. In most cases, it is due to the presence of diatomic carbon, a molecule that, when it breaks down under sunlight, emits an emerald glow. But the strange thing in this case was not the presence of green, but its intensity. Comet 3I Atlas seemed to be covered in a vivid hue, as if there were something in its composition that enhanced that glow. Enough for many astronomers to raise their eyebrows and admit, in public, that they did not know exactly what was happening. That is the heart of this story. A visitor from another star that, instead of behaving discreetly, decided to shine with a striking color and an intensity that is not easily explained. And that rarity, that spark that defies prediction, is what makes this story not just another one in the catalog of comets, but an open mystery. Before we continue exploring what this change means and what hypotheses are being considered, allow me to take a brief pause. If you enjoy listening to stories of the universe told calmly, designed to accompany your rest, this channel is your space. Here we tell cosmic stories not in a hurry, but with the serenity they deserve. You can subscribe to continue joining us on each journey, and if you wish, share in the comments where you are listening from. In this way, we transform the sky into a constellation of voices united by curiosity. And now let's return to the mystery, because what is happening with Comet 3I Atlas is not common. We are not talking about a simple increase in brightness, like those sometimes seen in local comets. We are talking about an interstellar object, a traveler that has crossed millions of years of solitude to appear in our cosmic neighborhood. And right at the moment we observe it, it gives us a spectacle that baffles even those who dedicate their lives to studying these phenomena. Why does it shine brighter? Why does it turn green with such intensity? What is inside it that makes it different? These are the questions that resonate in laboratories and observatories. And in these questions lies the promise of discoveries. Because every time the universe shows us something that doesn't fit, we have the opportunity to learn something new. Thus begins our journey around this visitor, not with certainties, but with an enigma that lights up green in the sky and forces us to look twice, to wonder what secrets it brings from the distant stars. In the next blocks, we will explore the hypotheses, the comparisons, and the reflections that this unusual comet awakens. But it all starts here, with a simple and powerful observation. Comet 3I Atlas is shining brighter than it should. And no one knows for sure why. The story of this comet began like so many others, quietly and without drawing too much attention. The Atlas system, whose full name is Asteroid Terrestrial Impact Last Alert System, has been monitoring the sky for years from several strategic points, including telescopes installed in Hawaii and Chile. Its task is clear: to detect and advance objects that could pose a risk to Earth. Normally, this translates into identifying near-Earth asteroids, rocks that pass at safe distances but could, in the future, cross our path. On the 7th of July 2025, one of those telescopes registered a faint, almost insignificant point of light that did not appear on known star maps. At first, it was nothing more than an anomaly, a flash that required confirmation. However, after several days of observations, it became clear that it was not a variable star or an artificial satellite. It was an object in motion, slow in appearance, but firm in its trajectory. The initial calculations showed something surprising. Its orbit was not closed like that of the planets, nor elliptical like that of common comets. It was hyperbolic, an open trajectory that clearly indicated that the body came from outside the solar system and that once it completed its journey, it would never return. That fact immediately made it an interstellar visitor. Only the third confirmed in human history, after Oumuamua in 2017 and Borisov in 2019. The finding generated excitement. For astronomers, each interstellar visitor is a unique opportunity, a time capsule from another star system. They are like bottles thrown into the cosmic sea that, after millions of years of travel, reach our celestial shores. We cannot decide when they appear or where they go, only observe them while they last. And the fact that in less than a decade we have already detected 3 objects of this type is, in itself, a reminder that the universe is full of wandering travelers. The comet was named 3I Atlas, where 3I indicates that it is the third confirmed interstellar object, and Atlas honors the system that discovered it. The name, strange for those not accustomed to astronomical nomenclatures, actually contains a whole story. That of a human project designed to watch the sky, and that of a visitor who, from another star, crossed our path. In the first days after its detection, expectations were clear. The models indicated that it would be a faint comet, visible only with powerful telescopes, and probably difficult to follow for a long time. No one expected a spectacle. The researchers were content to measure its composition, trace its orbit, and add a new case to the short list of interstellar objects. But the sky, as it so often does, decided to defy the predictions. As the days went by, the telescopes began to register something unusual. The comet was not only visible, but it was beginning to gain brightness more quickly than expected. The apparent magnitude, which measures the brightness we perceive from Earth, showed an unexpected increase. For astronomers, this was a surprise. An interstellar comet should not behave so actively so far from the Sun. The first photographs captured revealed a diffuse coma, that gaseous halo that surrounds the nucleus. In itself, this was not strange. What was unusual was the intensity with which the coma was expanding and the hue of its coloration, which was beginning to lean towards a faint green. It was too early to say for sure, but even from those initial days, some specialists began to suspect that this interstellar visitor held more than one secret. The initial discovery, then, was twofold. On the one hand, the confirmation of a new interstellar object. On the other, the feeling that it was not behaving like a simple comet. And that duality was what made it so attractive. It was not just an orbital datum, not just a number in a table. It was a living, changing phenomenon, capable of surprising even those who have been observing the sky for decades. For astronomy enthusiasts, the news was a gift. Within days, forums and online communities were filled with comments about the new visitor. Some shared the first images captured with medium-sized telescopes. Others tried to calculate when and where it would be visible. The general feeling was one of anticipation. It's not every day you get the chance to follow the passage of a comet that comes from another star. Meanwhile, professional astronomers were fine-tuning their instruments. They knew that time was limited. The comet would pass only once and then disappear into the darkness. Every night counted. Every spectrum recorded could reveal a new detail. And it was in those first weeks that the signs began to appear that 3I Atlas would not be just any visitor, but an enigmatic protagonist of September 2025. In retrospect, that initial discovery seems almost poetic. A faint point of light, barely perceptible, that in a matter of weeks transformed into a mystery that captured worldwide attention. As if the universe had reminded us that even in its apparent routine, it can always surprise us, and that behind every flash in the sky, a much more complex story than we imagine can be hidden. To understand why Comet 3I Atlas is surprising with its brightness, it is worth first remembering how comets behave in general. Broadly speaking, a comet is an icy nucleus composed of water, carbon dioxide, carbon monoxide, and other volatile materials mixed with dust and rock. While it remains in deep space, far from the sun, it is usually inactive, like a cold, dark block. But when it approaches our star, the solar radiation begins to heat its surface. This heating causes sublimation, that is, the direct transition of the ices to a gaseous state. The released gas carries dust particles with it, creating a diffuse atmosphere around the nucleus called a coma. The pressure of solar radiation and the solar wind pushes these materials back, forming the characteristic tails, one of ionized gas and another of dust. This is how comets acquire the luminous appearance that fascinates us so much. Under normal conditions, a comet's brightness is linked to its distance from the sun and the amount of material it releases. The closer it is, and the more volatiles it has, the brighter it will be. That is why most comets follow a predictable pattern, faint in the initial phases and progressively more intense as they approach their perihelion, the closest point to the sun in their orbit. The case of 3I Atlas, however, does not fit this pattern. From a still considerable distance, it began to brighten with a speed that was not expected. To put it in perspective, other interstellar comets, like Borisov, showed typical activity, releasing gases and forming tails when they got close enough. 3I Atlas, on the other hand, seemed to light up too early, as if its surface reacted differently to the solar heat. The apparent magnitude records confirmed this. Every week, the comet increased in brightness more than the models predicted. Astronomers accustomed to adjusting their calculations with slight variations were faced with an increase that was too marked to be attributed to chance. The comet was releasing more material than expected, and that made it stand out in the telescopes with an unusual glow. The obvious question was, what made it so different? One initial possibility was that the nucleus contained an exceptionally high amount of carbon dioxide. This gas, more volatile than water, can sublimate even at greater distances from the sun. If the comet is saturated with this compound, it could explain why it began to shine earlier than expected. By sublimating in large quantities, the carbon dioxide would have quickly inflated the coma, increasing its brightness. Another explanation proposed was the presence of fissures in the nucleus. If the comet's surface were fractured with deep cracks, the solar heat could penetrate more easily, reaching inner layers of ice. This would cause sudden releases of gas, called outbursts or cometary explosions. These temporary bursts could explain why the brightness increased in short periods, almost unpredictably. The third possibility is that we are dealing with a particularly porous nucleus, with an internal structure similar to a sponge. In that case, the volatiles would be trapped in cavities that, when opened by the effect of heat, would release large amounts of gas at once. This would also translate into a sudden increase in brightness, greater than what a comet with a more compact structure would show. Beyond the hypotheses, what is clear is that 3I Atlas is defying predictions. In science, this is not a problem, but an opportunity. Every anomaly is an invitation to review our models, to ask ourselves what we were overlooking. And in this case, the unexpected brightness opens the possibility of discovering aspects of the physics and chemistry of interstellar comets that we still do not know. The curious thing is that the brightness was not only increasing in quantity, but also in quality. It was not simply more light, but a glow tinged with a greenish hue, which gradually became more evident. This detail, which seemed secondary in the first records, soon became the heart of the mystery. Because while we know that certain compounds generate that tonality, the intensity shown by 3I Atlas was out of the ordinary. For astronomers, observing these types of phenomena is a reminder of how limited our experience is. In all the time we have been studying comets, we have barely had the opportunity to analyze a few interstellar visitors. And each of them has brought a different surprise. Oumuamua, with its strange shape and mysterious acceleration. Borisov, with its composition rich in carbon monoxide. And now, 3I Atlas, with its premature brightness and a bewildering green color. The increase in brightness also raises questions about the comet's stability. If it is releasing so much material ahead of time, could it disintegrate before it reaches its perihelion? History shows that some comets, like Ison in 2013, fragmented when the internal pressure exceeded the nucleus's resistance. If something similar were to happen to 3I Atlas, we might lose the opportunity to observe it in its maximum splendor. But in return, we would obtain valuable information about its interior. In the end, the exact reason for its brightness remains a mystery. Perhaps it is a mixture of carbon dioxide, internal fissures, and uncommon materials. Perhaps we are facing a phenomenon that we still do not fully understand. The only thing for sure is that Comet 3I Atlas, by shining brighter than expected, forces us to look closer, to dedicate more telescope time, to refine our theories. And that is, perhaps, the greatest lesson of this block. The sky does not always follow our calculations. Sometimes, the objects that should go unnoticed decide to shine brightly, as if they want to make sure we do not ignore them. 3I Atlas will be no exception. It is a reminder that even in the vastness of the cosmos, mysteries light up to call our attention. Comets usually appear as white or bluish smudges in the night sky, their tails pushed by the solar wind. Light up with pale reflections, almost always discreet, except in the spectacular cases that become world news. But 3I Atlas decided to follow a different path. Its poma began to be tinged with an intense green, a color so striking that even in long-exposure photographs, it became impossible to ignore. The green in comets, in itself, is not an absolute rarity. During the 20th and the beginning of the 21st century, we have seen comets that acquired that tone. The most accepted explanation is the presence of diatonic carbon, a molecule composed of two bonded carbon atoms, that when exposed to the sun's ultraviolet radiation, disintegrates and releases an emerald glow. It is a well-documented phenomenon that usually appears in the outer layers of comets when they begin to sublimate. What makes 3I Atlas an enigma is not so much the appearance of the green, but its intensity. Spectroscopic records show an abundance of this glow that exceeds what is expected. In other words, the comet not only has diatomic carbon, it seems to have it in disproportionate amounts, or at least to release it in an unusually efficient way. This makes its coma not just a greenish veil, but a glow that dominates its appearance. Astronomers began to wonder, Why so green? What internal or chemical conditions cause this phenomenon? Some hypotheses suggest that the comet contains materials rich in organic compounds, which, upon disintegration, produce more diatomic carbon than usual. Others suggest that the porous structure of the nucleus allows these compounds to escape in large volumes, intensifying the effect. Another possibility is that the comet comes from a particularly cold region of its original system, where certain compounds could have been preserved in large quantities. If so, what we are seeing is not just a pretty color, but the chemical footprint of a distant world, a kind of signature that tells us about the conditions of another star, of another protoplanetary disk that once existed in the past. For science, this detail is fascinating. Every color in a comet is a clue. Blue is usually associated with ionized carbon monoxide, white with sunlight reflected off the dust, green with diatomic carbon, and in this cosmic palette, clues about the origin and composition of these bodies are hidden. Seeing 3I Atlas turn green is like receiving a chemical message from another star, a reminder that the diversity of worlds is infinite. The public, for its part, reacted with the fascination that striking images arouse. Social media was filled with photographs and simulations that showed the comet as an emerald jewel crossing the sky. Many informally named it the Interstellar Green Comet, and although that is not its official name, it well reflects the impression it makes on those who observe it. However, between the beauty and the mystery, there is an inevitable tension. Astronomers know that the intensity of the green raises difficult questions. Why didn't previous models predict this abundance? What kind of internal processes can generate such a persistent glow? And above all, what does this mean for our understanding of interstellar comets? Some specialists have compared the phenomenon to that of Comet Lovejoy, observed in 2015, which also showed a vibrant green. But even in that case, the tone was fleeting and less marked than in 3I Atlas. Here we are talking about a visitor that, from its early stages of activity, has presented itself tinged with that color, as if it were an intrinsic part of its identity. Imagine for a moment what this means. From Earth, millions of people could observe in the near future a greenish point in the sky, knowing that it is a traveler that will never return. That tone will become its visual signature, the detail that distinguishes it from other comets. And when it disappears into the darkness, it will remain in our collective memory as that green comet that came from another star. The mystery of the green also has deeper implications. If the comet indeed contains an extraordinary abundance of organic compounds, we would be facing direct testimony to the chemical richness of other star systems. And that would lead us to an exciting conclusion. The chemistry necessary to form complex molecules, perhaps precursors to life, is not exclusive to our cosmic neighborhood. It is also present in the fragments that travel from distant stars. At this point, it is worth pausing on the paradox. What to the human eye is a simple, striking color, for science is a window to fundamental questions. How are comets formed in other systems? What chemical differences exist with ours? What does this tell us about the universality of cosmic processes? In that paradox lies the beauty of astronomy. Behind a green glow, there is a story that connects worlds. Thus, the mystery of the green is not just an aesthetic curiosity, but a reminder that each interstellar visitor is a fleeting teacher. 3I Atlas does not just pass by. It leaves clues, sows questions, forces us to rethink what we know. And although astronomers do not yet have all the answers, the intensity of that color is an invitation to continue observing, measuring, and dreaming. Because in the end, the green we see in the sky is more than a physical phenomenon. It is a symbol. It represents the universe's ability to surprise us, to break our expectations, to show us that there are still secrets hidden in the vastness. And it also represents the humility with which we must look at the cosmos, knowing that every glow can be the key to a greater enigma. The mystery of the green color in 3I Atlas becomes even more interesting when we put it in perspective with other comets we have observed in our own solar system. Because although the emerald tone is not unprecedented, what is happening with this interstellar visitor seems to challenge what we thought we knew. One of the most remembered examples is Comet Lovejoy, discovered in 2011. During its approach to the Sun, it showed a greenish glow in its coma, visible enough to attract the attention of even casual observers. The explanation was the usual one: the presence of diatomic carbon, a fragile molecule that forms when more complex organic compounds disintegrate under ultraviolet light. Comet Lovejoy earned, for a time, the nickname the Green Comet. However, that tone was not permanent, nor as intense as what we see today in 3I Atlas. It was a fleeting hue that faded as it advanced in its trajectory. Another case was Comet Swan, observed in 2020. It also presented a greenish coloration, although fainter. In its case, the activity was brief, a sudden increase in brightness, followed by a rapid disappearance. Astronomers explained that it had probably fragmented, losing a large part of its mass before reaching its maximum splendor. The lesson was clear. Not all green comets maintain their color or their brightness. Many disintegrate along the way, leaving behind only a memory in the form of images captured by amateurs and professional telescopes. More recently, in 2023, Comet C 2022 E3 ZTF became a media phenomenon for its greenish hue. Nicknamed the February Green Comet, it generated headlines around the world. But here, too, the green was a fleeting detail, a temporary phase of its evolution. Although millions of people were able to observe it, the phenomenon did not surprise astronomers too much. It fit within what was expected for a comet of local origin. Compared to these cases, the brightness of 3I Atlas acquires an even more enigmatic hue. It is not just an emerald color that appears and disappears. In this visitor, the green seems to be a persistent, almost defining feature. From the early stages of its approach to the Sun, the comet showed this tonality with an intensity out of the ordinary. And instead of fading quickly, as happened with other comets, it has remained firm, even increasing over time. This difference opens an inevitable question: what makes this interstellar comet behave so differently from local ones? One hypothesis is that it comes from a much colder region than our Oort cloud, where the comets of our system were formed. There, fragile compounds like carbon monoxide or ammonia could have been preserved in greater quantities. If 3I Atlas is rich in these types of materials, then each approach to the Sun translates into a more dramatic release of gases, amplifying the visual effect. Another key difference is the structure of the nucleus. Local comets have passed near the Sun several times, which means they have lost some of their outermost volatiles. One could say they are processed by repeated visits. 3I Atlas, on the other hand, is a virgin comet, a fragment that had never felt the heat of a star like ours up close. Its surface is intact, loaded with fresh materials that react intensely to the first contact with solar radiation. That could explain both its unexpected brightness and the strength of the green tone that characterizes it. The comparison also allows us to appreciate how fortunate we are. When we observe a local comet, we are seeing an object that has lived its history almost exclusively in our solar system. It is valuable, yes, but predictable to a certain degree. When we observe 3I Atlas, on the other hand, we are looking at a piece of another star system, an alien chemistry that traveled for millions of years to find us. Its color, its brightness, and its anomalies are not just curiosities. They are signs of processes that occurred far away under other stars and in other times. Astronomers aware of this rarity, have begun to compare their data with that of Borisov, the other confirmed interstellar comet. Borisov also showed chemical peculiarities, in particular, an abundance of carbon monoxide much greater than that of local comets. This reinforced the idea that interstellar visitors can have radically different compositions than what we know. If Borisov was the example of an excess of CO, 3I Atlas could be the example of an excess of compounds that generate green. Looking at these comparisons, an interesting pattern emerges. Each interstellar visitor brings with it a trait that defies the norm. Oumuamua had a strange shape, an inexplicable acceleration. Borisov showed a singular chemistry. And now, 3I Atlas exhibits a bewildering greenish glow. It seems as if the universe has insisted on reminding us that cosmic diversity is greater than we imagined. Beyond the scientific, there is a human aspect to this comparison. When millions of people looked at the sky in 2023 to see the green comet ZTF, they did so knowing that it was a fleeting event, but also a common one. In contrast, when observing 3I Atlas, we are aware that it is not a usual neighbor, but an unrepeatable visitor. It will never return. Its color and its brightness are not phases that we can expect again in decades. They are unique, unrepeatable. Like a message written in the sky that fades quickly. And that ultimately is what makes this comparison so powerful. The local green comets have shown us that chemistry can dye space with color. But 3I Atlas teaches us that when that chemistry comes from another star system, the effect ceases to be a simple curiosity and becomes a profound mystery. It is not just green. It is the green of another sun, of another time, of another origin. Each comet hides secrets, but usually astronomers know with some precision what to expect. The laws of physics are clear, and the processes of sublimation are quite well understood. That is why, when a local comet begins to shine more, it is usually easy to find the explanation: an increase in temperature, a crack in the nucleus, a sudden release of dust. But with 3I Atlas, the case has been different. It not only shines more, but it does so in a way that breaks the usual models. The first reports of apparent magnitude had already been surprising. The comet should have remained faint at great distances from the sun, but in a matter of weeks, it began to be brighter than predicted. When the observation teams compared their data with the initial simulations, they noticed that the difference was too wide. The increase could not be explained with simple adjustments. Something else was happening inside it. The bewilderment increased when the spectra revealed the intensity of the green color. Yes, diatomic carbon was the obvious culprit, but the amount detected did not fit what was expected from an object of its size and trajectory. In other words, the comet seemed to be releasing more than it should. For some researchers, this suggested that it is composed of uncommon materials, or that it formed in radically different conditions from the comets of our system. But the most intriguing thing was the speed of the changes. In local comets, increases in brightness usually follow relatively smooth patterns. In 3I Atlas, however, the behavior was erratic. Sometimes it shone more than expected in a matter of hours, as if there were internal eruptions releasing gas explosively. These sudden variations led some astronomers to speak of an impulsive comet, a visitor that is not easily predicted. The meetings in astronomy institutes reflected that mixture of fascination and discomfort. There were those who tried to fit the data into known explanations: sublimation of carbon dioxide, fissures, outbursts. And there were those who suggested that we were seeing something new, an unprecedented phenomenon. In any case, the answer was always the same: we do not know for sure. That phrase, "we don't know," was repeated in interviews and press releases, not as a sign of ignorance, but as a demonstration of scientific honesty. Because science, in the end, advances by recognizing its limits. 3i Atlas became a mirror of those limits. It reminded the community that no matter how advanced we are, there are still phenomena that escape our predictions. Another disconcerting point was the comparison with Borisov, the interstellar comet detected in 2019. Borisov, although strange for its abundance of carbon monoxide, behaved essentially like a typical comet, a coma, visible tails, sublimation according to the solar distance. 3i Atlas, on the other hand, seems to follow a different script, as if it had decided to draw attention with its green glow and its unpredictable increases in brightness. Some astronomers began to propose more daring hypotheses. Could it be a fractured object with multiple nuclei that release material independently? Or perhaps a comet with an exceptionally high percentage of volatile organic compounds capable of amplifying the effect of diatomic carbon? Each proposal was accompanied by warnings. They are just conjectures. We need more data. The truth is that the most powerful telescopes, like the James Webb, began to point towards the visitor. The hope was to obtain detailed infrared spectra, capable of revealing the chemical signature of its coma. With that information, perhaps we could confirm which compounds were behind the mystery. But even with those instruments, the explanation was not immediate. The comet remained a puzzle. The bewilderment also reached the public. Media and popular science magazines highlighted the phrase that many astronomers repeated: "We don't know why." For the general public, hearing that experts do not have absolute answers can be surprising, even unsettling. But deep down, that uncertainty is part of what makes the story so attractive. The universe still holds secrets, and 3i Atlas is proof of that. Perhaps the most valuable thing about this bewilderment is that it forces us to rethink basic questions. Are interstellar comets so different from ours? Do completely alien chemical families exist that we don't know about? To what extent can we extrapolate what we have learned in the solar system to the rest of the galaxy? Every time a visitor breaks expectations, those questions return with more force. In the end, what baffles astronomers is not just the color or the brightness, but the reminder that the universe does not always follow our rules. That even with refined models and advanced telescopes, there are still surprises capable of shaking us. And that is, ultimately, the essence of astronomy: to face the unknown, to recognize what we do not understand, and to advance little by little towards understanding. Thus, 3i Atlas has earned a special place not only in the scientific records, but also in the collective memory of the astronomical community. Because beyond the data, it reminded us of something essential: the cosmos will always have the last word. When astronomers face a mystery like that of 3i Atlas, the first thing is to look for explanations within the known. And one of the most reasonable hypotheses that emerged was the abundance of carbon dioxide in the comet's nucleus. Carbon dioxide, also called CO2, is a very common gas in the universe, and also in comets. The interesting thing is that, unlike water, it does not need to be so close to the sun to sublimate. While water ice remains stable in cold regions and only becomes active when it gets quite close to our star, carbon dioxide can sublimate at much greater distances. This means that if a comet is saturated with CO2, it could start to show activity very early in its journey towards perihelion. This would fit with what we saw in 3i Atlas. From the initial stages, it began to release gas and shine more than expected. The records suggest that, even when it was still far away, it already showed an active coma. For some researchers, this was the clue that the nucleus must be loaded with carbon dioxide in uncommon amounts. But how would a comet come to have so much CO2 inside it? The possible explanation is found in its origin. If 3i Atlas comes from a very distant region of its native system, in the confines of a comet cloud similar to our Oort cloud. The temperatures there would have been extremely low. In that environment, volatile compounds such as carbon dioxide, carbon monoxide, and even methane could freeze in large quantities and be preserved for millions of years. Thus, when a fragment is ejected by gravitational interactions and begins its interstellar journey, it carries with it an abundant reserve of these ices. Upon arriving in our solar system, that reserve begins to react with the sunlight. And if the proportion of CO2 is high, the result is a comet that shines much earlier than expected, because it releases gas in quantities that amplify its coma. This could be the case of 3I Atlas, a comet that does not play by the same rules as the local ones, because its chemical reserves are different from the origin. Furthermore, carbon dioxide does not act alone. As it sublimates, it carries with it dust particles and other organic compounds. That dust, dispersed around the nucleus, reflects sunlight and increases the apparent magnitude of the comet. In other words, the excess of CO2 not only explains the early activity, but also the unexpected brightness. But here an interesting nuance arises. The characteristic green of 3I Atlas is more directly associated with diatomic carbon than with carbon dioxide. How are they related then? The connection could be in the processes of chemical decomposition. When CO2 and other organic compounds fragment under ultraviolet radiation, they can release intermediate molecules that in turn break into diatomic carbon. In that sense, an unusual abundance of CO2 could also facilitate a greater production of diatomic carbon and, therefore, a more intense green glow. The scientists who support this hypothesis point out that we already have precedents. Some local comets rich in CO2 have shown similar behaviors, although never with the intensity of 3I Atlas. The difference would be in the scale. While ours have limited reserves, this interstellar visitor seems to bring a much larger cargo. Now, accepting this explanation does not mean solving the whole enigma. Although CO2 can justify the early brightness and part of the green color, it does not necessarily explain the persistence or the intensity of the phenomenon. In local comets, the effect usually diminishes as they approach the sun and other processes dominate. In contrast, in 3I Atlas, the green seems to have consolidated as a stable feature, which suggests that it may not be just carbon dioxide, but a more complex combination of factors. Even with these limitations, the hypothesis of abundant CO2 is attractive because it does not require inventing new processes. It is based on what we already know about cometary chemistry, just taken to an extreme. That is, a case of excess, and many times in science, excesses are what reveal the limits of our categories. Imagine for a moment what it would mean to confirm this theory. It would be like opening a window to the past of another star system. We would see that in the distant edges of that star, the conditions allowed carbon dioxide to accumulate in immense quantities, and that now, millions of years later, a fragment of that system is traveling through our vicinity, showing us with its greenish glow the footprint of its origin. The idea is poetic. The green of 3I Atlas would be, in reality, the chemical memory of a distant world, a sign that the universe is diverse, even in the smallest things, in a simple piece of ice that crossed the galaxy until it met our gaze. However, the scientific community remains cautious. No telescope has yet absolutely confirmed the exact composition of the comet. There are indications, there are models, but no conclusive evidence. And as long as we do not have that data, the hypothesis of abundant carbon dioxide will remain just that, a hypothesis. What we can affirm is that, although it does not solve the whole mystery, this explanation offers a solid basis. It reminds us that we do not always need to resort to the impossible to understand the strange. Sometimes it is enough to consider that in such a vast universe, the variety of chemical combinations can produce unexpected results. And in this case, the result is a comet that shines too soon, too strong, and too green. A visitor that forces us to look closer, and that, with its simple presence, challenges the comfort of our models. If the abundance of carbon dioxide is a plausible explanation for the brightness and color of 3I Atlas, another hypothesis points to the internal structure of the comet. Unlike what we usually imagine, comets are not solid, compact spheres, but fragile conglomerates, almost like cosmic debris held together with ice. That is why it is not uncommon for them to develop fissures, cavities, and deep cracks that affect their behavior when they approach the sun. In this scenario, 3I Atlas could be a particularly fractured comet, with an interior full of tunnels and voids. Upon receiving solar radiation, these cracks would allow heat to quickly penetrate into deeper layers of the nucleus. Consequently, ices that would normally remain stable would begin to sublimate at once, releasing large volumes of gas in short periods. The result? A sudden increase in brightness and the formation of visible jets in the coma. These types of phenomena are known as cometary outbursts. In the records of astronomy, there are multiple examples of comets that, from one day to the next, dramatically increase their luminosity. Comet 17P Holmes, for example, in 2007, multiplied its brightness by 1,000,000 in just a few hours, going from being invisible to the human eye to becoming an object observable with the naked eye in the night sky. In that case, the most accepted explanation was the rupture of a surface layer that released accumulated gas inside. If something similar is happening in 3I Atlas, then its changes in brightness and the intensity of its green could be due to sudden releases of material trapped in internal cavities. The cracks would act as valves that, when opened, expel gas and dust at high speeds. This would not only increase the luminosity of the comet, but it could also favor the release of compounds that generate the green glow, such as diatomic carbon. The hypothesis of the internal fracture also has another advantage. It explains the unpredictable variability that has been observed. Unlike the gradual sublimation of carbon dioxide, internal bursts occur erratically. They depend on when and where the layers of ice break, something that cannot be calculated with precision. This would fit with the records that show that 3I Atlas does not follow a smooth pattern, but presents sharp increases in short periods of time. But here an additional concern arises. If the comet is so fractured, how stable is it really? History shows that many comets have ended up fragmenting into multiple pieces due to these internal tensions. Comet Shoemaker-Levy 9, for example, broke into fragments before crashing into Jupiter in 1994. More recently, Comet Ison, which in 2013 was announced as the comet of the century, ended up disintegrating as it got too close to the Sun. Could the same thing happen to 3I Atlas? It is a possibility that astronomers do not rule out. If the nucleus is too weakened by cracks and cavities, the encounter with the solar heat could be more than it can withstand. In that case, instead of a prolonged spectacle, we could witness a sudden disintegration, with the comet breaking into multiple fragments that would disperse in space. Paradoxically, for science, this would not be a loss, but an opportunity. The fragmentation would expose internal materials that would normally remain hidden. Each release piece would reveal clues about the composition and structure of the comet. It would be like opening an interstellar time capsule and observing its interior in detail. For the public, of course, the feeling would be different. Many would feel that the opportunity to see an interstellar comet in its maximum splendor was lost. Another consequence of the internal fracture could be the formation of multiple secondary nuclei. Sometimes, when a comet partially fragments, the pieces do not disperse completely, but remain in a close orbit. This creates the illusion of a double or multiple comet. If something like this were to happen with 3I Atlas, the sight would be even more spectacular. Several bright points, each with its own tail, traveling together in the firmament. The proponents of this hypothesis argue that the intensity of the green could also reinforce the idea of internal bursts. When a comet releases large amounts of gas in a short time, that gas is exposed to solar radiation more intensely, generating a stronger visible glow. Thus, each internal explosion would translate into a burst of color, as if the comet were breathing heavily at irregular intervals. However, like any hypothesis, this one also has limitations. Not all increases in brightness can be attributed to outbursts, and the pattern observed in 3I Atlas, although erratic, seems more constant than typical isolated bursts. Perhaps the truth lies somewhere in between, a fractured nucleus that releases gas in a sustained manner, but with stronger pulses at certain times. What is certain is that, if confirmed, the hypothesis of the internal fracture would add a dramatic nuance to the comet's story. We would not just be seeing an interstellar traveler with a strange color, but an object fighting to stay whole on its first and only visit to our system. A visitor that could, at any moment, fall apart before our eyes, reminding us how fragile these cosmic time capsules are. And although we do not have certainty about what its fate will be, the simple fact of considering this possibility connects us with a broader truth. The universe is not made only of eternal and stable stars. It is also populated by ephemeral bodies, fragments that are born, transform, and die in short timescales. 3I Atlas, with its internal cracks and its possible bursts, is a reminder of that fragility. When the explanation with carbon dioxide is incomplete and the theory of a fractured nucleus does not fully answer, a third possibility arises, much more daring and speculative, that Comet 3I Atlas is composed of rare materials or exotic compounds that are not common in the comets we know. The comets of our solar system are usually formed from a mixture of water ice, carbon dioxide, carbon monoxide, methane, ammonia, and silicate dust. That basic recipe is repeated with slight variations in most of the cases studied. But an interstellar object, forged in a completely different star system, could have been cooked with different ingredients. In that scenario, what we see today would be the result of an alien chemistry, not in the sense of extraterrestrial life, but of a chemical composition forged under conditions very different from those of our Sun. Sun researchers have raised the idea that 3I Atlas could contain unusual proportions of volatile metals. For example, traces of nickel or iron that, when sublimated, produce unexpected emissions. We have already seen in other comets spectral signals of heavy metals, although in minimal quantities. If in this interstellar visitor the concentration were higher, it could alter the color and brightness significantly. Another line of speculation suggests that the comet could contain complex organic molecules that are not easily found in local comets. Compounds such as polycyclic aromatic hydrocarbons, which are abundant in the interstellar medium, could be released upon interacting with solar radiation. These compounds, when decomposed, can produce more intense green light emissions, contributing to the striking appearance of 3I Atlas. In this sense, what we observe could be the chemical signature of another planetary system. If in that native system different conditions existed, a colder star, a molecular cloud rich in certain elements, or different formation processes, the comets that emerged there would have a unique composition. And now, one of those fragments is passing through our sky, showing us a spectrum that does not fit into our categories. The hypothesis of exotic compounds also connects with something we saw in Borisov, the second confirmed interstellar object. Its spectra showed an excess of carbon monoxide that baffled astronomers. No one expected to find so much in a comet, because in our solar system, the comets that contain it in large quantities usually come from very specific regions. But there was Borisov, showing that the chemistry in other places can be radically different. If Borisov was the example of a hyper-rich in CO comet, then 3I Atlas could be the example of a hyper-rich in green compounds comet, perhaps diatomic carbon in extraordinary quantities, perhaps derivatives of complex molecules that we had never before seen sublimate in a comet. Imagine what this would imply. It would mean that not all planetary systems produce comets with the same recipes, that the chemical diversity of the universe is much broader than we assume, and that each interstellar visitor is, in a way, an ambassador of that diversity. 3I Atlas would be here to remind us that we cannot universalize what we see at home, because outside there are different rules. From a philosophical point of view, this hypothesis is exciting. To think that the green color we see in the sky today is in reality the footprint of another star, of a place we will never visit, connects us with the vastness of the cosmos in an intimate way. It is as if a fragment of that distant world had sent us a business card in the form of light. Of course, like any hypothesis, it has detractors. The more cautious point out that talking about exotic compounds is too speculative without solid data. The most advanced telescopes, like the James Webb, will be able to offer clues by analyzing the infrared light, but until then, talking about strange molecules is more an exercise of imagination than a scientific certainty. And yet, imagination also has its value. It allows us to think outside the predictable, to open doors to possibilities that we would otherwise overlook. One detail in favor of this hypothesis is that the intensity of the green in 3I Atlas is surprising not only for what is seen, but also for what is not seen. Some preliminary spectra show that while the green dominates, other typical emissions seem weaker than expected. This suggests that the comet's chemistry does not follow the traditional pattern. It is not that it has more of everything, but that it could have a lot of something specific and little of the rest. That specialization would be precisely what makes it so different. Let's also think about the symbolic. Every time we have studied an interstellar object, we have discovered something that defies the norm. Oumuamua broke our schemes with its elongated shape and its strange acceleration. Borisov taught us that there could be comets with atypical chemical compositions. And now, 3I Atlas offers us this enigmatic green. It is as if the universe were telling us, don't think you know everything. There will always be surprises. Thus, the hypothesis of rare materials is not just a possible explanation. It is a reminder that we must be prepared for the unexpected. Because if the history of astronomy has taught us anything, it is that the cosmos does not repeat itself, but invents infinite variations. In conclusion, to think that 3I Atlas contains exotic compounds is to accept that we are facing something genuinely new. Perhaps, when its spectra are analyzed in more detail, we will discover familiar chemical names only in extreme proportions. Or perhaps, we will find molecules that we have never before seen in a comet. In both cases, the message will be the same. This interstellar visitor did not come to go unnoticed. When we talk about an interstellar comet like 3I Atlas, we are not only interested in what we have already seen, but also in what is to come. The future of its observations is as intriguing as its present, because every step it takes in its trajectory can offer us new clues. And in this case, the interest is twofold. On the one hand, the mystery of its green brightness, and on the other, the unrepeatable opportunity to study a visitor that will never return. The future scenarios begin with its gradual approach to the Sun. In the coming months, as it approaches perihelion, the comet's activity should intensify. The solar radiation will heat its nucleus even more, sublimating layers of ice that have until now remained inactive. If the carbon dioxide hypothesis is correct, we will see an even greater explosion of activity, with jets that will feed the coma and expand the tails. On the other hand, if what dominates are internal fractures, we could expect sudden bursts, with variations in brightness as unpredictable as they are surprising. One possible scenario is that 3I Atlas reaches a brightness visible to the naked eye, something that would make it a global phenomenon. Not all comets achieve that privilege. Many remain confined to the gaze of telescopes. But if this visitor maintains the current trend, it could become a spectacle that millions of people see from their balconies and gardens. The possibility of observing an interstellar comet directly with the eyes would be a historic event, one that would be engraved in the collective memory as one of the great moments of contemporary astronomy. Another scenario, less optimistic, is that of fragmentation. If the nucleus is too weakened, the solar heat could cause it to break into pieces before reaching its maximum splendor. We have already seen cases like this. Comet Ison in 2013 promised an unforgettable show, but ended up disintegrating as it got too close to the Sun. In that case, what was left were just scattered debris, observable only with instruments. If the same thing happens to 3I Atlas, we would lose the opportunity to witness a bright comet in the night sky. However, for scientists it would be equally valuable. The fragmentation would reveal internal materials that we could not otherwise study. It is also the possibility that the comet will show an intermediate behavior, that it will partially survive, losing fragments but retaining a main nucleus. In that case, we could see a double or multiple spectacle, with several nuclei shining together, each with its own tail. That scenario would be spectacular, although also more chaotic from a scientific point of view. Beyond its physical destiny, the future scenarios include the ability of our instruments to study it. The James Webb Space Telescope has already demonstrated its power to analyze comets, detecting compounds at infrared wavelengths that telescopes on the ground cannot observe. Pointing that eye at the interstellar visitor could reveal details of its chemistry that today we can only guess at. It is possible that, thanks to that data, we can confirm if it contains exotic compounds or if it is simply saturated with already known molecules in extreme proportions. Radio telescopes will also play an important role. By observing the emissions of certain gases at specific frequencies, they can directly measure the amount of molecules released. Thus, we will know if carbon dioxide, carbon monoxide, or ammonia are behind the intensity of its brightness. Each antenna directed at it will be like a giant ear listening to what the comet has to say. Another relevant factor will be the participation of amateur observers. In the era of digital astronomy, amateur astronomers have increasingly sophisticated equipment capable of capturing high-quality images. Their contributions have already been key in tracking local comets, and in the case of 3I/Atlas, they could be vital. Thousands of telescopes scattered around the planet recording its evolution will give us an almost continuous view of what is happening, something impossible to achieve only with the large observatories. But perhaps the most fascinating scenario is that of international collaboration. 3I Atlas is a unique visitor, and its study requires the combined effort of scientists from all over the world. Teams in America, Europe, Asia, and Oceania will coordinate observations so as not to miss any detail of its passage. This cooperation, beyond borders, is a reminder that the universe belongs to all of us and that its mysteries can unite us instead of dividing us. From a narrative point of view, all these scenarios make 3I Atlas an open story. It can become the brightest comet of the decade. It can disintegrate in silence, or it can surprise us with an outcome that no one has foreseen. Whatever the case, the important thing is that we are here to see it, to record it, to ask ourselves what it is showing us. And there is an additional nuance. The leak with solar activity. Right in this same period, the sun is showing a more restless behavior than expected, with more active sunspots and intense geomagnetic storms. Some have wondered, in a speculative tone, if there is any connection between the two phenomena. Could the passage of an interstellar comet have any effect on the sun? Science tells us no. The sun is too massive for such a small object to alter it. But the temporal coincidence adds a dramatic air to the story, as if the sky were synchronizing two different shows. In the end, the future observation scenarios are not just technical predictions. They are possible stories, narratives that open up before us. In them, expectation, uncertainty, and the emotion of looking at the sky, knowing that something unrepeatable is underway, are mixed. And that is, perhaps, the greatest lesson. That no matter what the outcome is, what matters is the opportunity to witness it. Because 3I Atlas is not just another comet. It is a messenger from another world, a traveler that crossed the galaxy to show us a green glow that we still do not understand. And every day that passes brings us closer to the moment when it will reveal its secrets or disappear in silence. That cosmic suspense, that weight full of possibilities, is what makes all eyes be on it. The universe does not understand human calendars, and yet, sometimes it seems that the stars decide to agree to give us a parade on very precise dates. That is what has happened in September of 2025, a month that will be engraved in the memory of astronomy for the unusual number of cosmic visitors that have gathered in our sky. It is not just about Comet 3I Atlas, although it is, without a doubt, the main star of the show. Around it, other secondary actors have appeared almost at the same time. Asteroids that passed relatively close to Earth, small fragments that burned up like shooting stars upon entering the atmosphere, and other less notorious comets that began to be visible with telescopes. The firmament became a crowded stage, a reminder that we live in a dynamic neighborhood. Always in motion, for astronomers, this coincidence is a source of fascination. The simultaneous arrival of several objects does not necessarily imply a causal relationship. It is not that they have agreed to visit us at the same time, but it does reveal something important. The vastness of space is full of travelers, and we are just a point in their trajectories. That several coincide in the same month is a statistical rarity, but also a reminder of how little we control and how much we still have to discover. The observatories recorded, for example, the close passage of an asteroid of a few tens of meters, which crossed at a safe distance but close enough to be monitored with attention. In parallel, the radars detected smaller fragments that, upon entering the atmosphere, produced luminous shows visible in different regions of the planet. Those flashes, although brief, added to the atmosphere of expectation that already surrounded the interstellar green comet. The astronomical community began to speak of September as a month overloaded with visitors. And there was no shortage of comparisons with other historical moments. In 1997, Comet Hale-Bopp coincided with a period of intense solar activity, and millions of people remembered it as an unforgettable spectacle. In 2020, Comet Neowise became visible to the naked eye in the middle of the boreal summer, offering iconic images. But what is happening in 2025 is different. It is not a single protagonist, but a set of celestial actors sharing the stage, as if the universe had decided to schedule a cosmic festival. Among all of them, 3I Atlas stands out for its unrepeatable character. The other bodies we see now will return at some point or in other forms, because they are part of our solar system. But the interstellar green comet is unique. Once it moves away, there will be no second chance. That is the difference that makes it the undisputed protagonist of the month. For the general public, this parade has been an invitation to look up at the sky more frequently. Those who usually ignore the firmament began to look with curiosity, wondering what that green dot that appeared in the news was, or what it meant for an asteroid to pass close to Earth. Online forums and social media were filled with questions, images, and comments. Suddenly, the sky became a topic of daily conversation again, something that has always had a special power, to remind us that we all share the same starry roof. The most interesting thing about this coincidence is how it changes our perception. A comet by itself already generates admiration, but several phenomena together create the feeling that something extraordinary is happening. Not because there is a physical connection between them, but because our mind tends to look for patterns, to interpret simultaneity as a message. And although science insists that they are coincidences, the human narrative turns it into a story, a month in which the sky was more crowded than ever. For scientists, moreover, this abundance of objects offers a golden opportunity. Each comet, each asteroid, and each fragment observed in September becomes another piece of data, a piece that expands the map of our cosmic environment. And having several examples simultaneously allows us to compare behaviors, contrast compositions, and look for patterns. In that sense, September 2025 is not just a visual spectacle. It is a natural laboratory in which multiple visitors offer their secrets at the same time. The rarity also leads us to reflect on the fragility of our place in the cosmos. Seeing asteroids pass by, even without real danger, reminds us that we live in a dynamic system where trajectories can change and close encounters are part of natural history. And seeing an interstellar comet cross our sky is an even deeper lesson. We are just a way station on a much larger journey. Perhaps centuries from now, someone will remember this month as the time when a green comet from another star lit up the sky along with a shower of smaller visitors. And although science will describe it with cold data, in the collective memory, the feeling will remain that September was special, a month in which the universe gave us an unrepeatable spectacle. Thus, the rarity of having so many visitors in the same month is not just a curious statistic. It is a reminder that the sky always holds surprises, and that sometimes it decides to show them all at once, as if it wanted to make sure we do not forget to look up. Science is clear on something. A comet, no matter how striking, does not have the power to alter the behavior of a star like the Sun. The difference in scales is abysmal. Our star is a plasmasphere of 1 million kilometers in diameter, with a mass that exceeds that of the Earth by 300,000 times. A comet, in comparison, is just a speck of cosmic dust, and yet, the human imagination cannot help but play with alternative scenarios. What if 3I Atlas were, somehow, related to the recent anomalies in solar activity? In recent months, the solar observatories have recorded a more restless behavior than expected. Sunspots have appeared more frequently, coronal mass ejections have been more intense, and the Sun's magnetic field seems to be going through a period of unusual turbulence. Officially, astronomers attribute it to the natural 11-year cycle, which is in a particularly active phase, but coinciding with the arrival of such a peculiar interstellar visitor. The question arises almost inevitably. Could there be a connection? Let's imagine for a moment that there is, not a direct physical interaction, because a comet could never alter the dynamics of a star, but some more subtle, almost mysterious effect. For example, That 3I Atlas brought with it particles or magnetic fields dragged along during its long interstellar journey. As it approached the Sun, these particles could interact with the heliosphere, generating small disturbances that would be amplified in the solar system. Another even more daring speculation would be to think that the orbit of 3I/Atlas, by crossing regions of space loaded with dust and gas, is stirring up the local interstellar medium. That dust, upon encountering the solar wind, could be contributing to small variations that the observatories detect as anomalies. It would not be the comet itself that alters the Sun, but the invisible environment it carries with it, like a ship that leads waves in the water far beyond its size. From a narrative point of view, these ideas are irresistible, because they connect two stories that are already fascinating in themselves, that of a green interstellar comet and that of a sun that seems more restless than usual. Together, they form a story that awakens the imagination, a visitor that, with its fleeting passage, alters the very heart of our star. And what if 3I Atlas is not just a messenger from another system, but also a catalyst for solar phenomena? And what if its intense green is not just a chemical reflection, but a sign that it carries something that interacts with our Sun? Of course, science sets limits. There is no proof that something like this is possible. But speculating is not the same as affirming. It is an exercise of imagination that helps us to value even more the extraordinariness of the moment we are living. Because even if there is no real connection, the temporal coincidence is enough to ignite our curiosity. In the history of humanity, comets were always associated with celestial signs. Ancient chronicles speak of comets that appeared just before wars, plagues, or catastrophes. They were seen as omens, as messengers that brought warnings. Today, with modern science, we know that these links were symbolic, not causal. But it is still striking that even now, an interstellar comet coincides with an uncontrolled sun. It is as if the cosmos were giving us back, in a poetic way, that ancient instinct to look for meanings in the sky. If we play a little more with this speculative scenario, we could imagine that 3I Atlas carries within it relict magnetic fields from another star. These fields, released in the form of plasma as they approach the Sun, could dialogue with the solar-magnetic field, producing unexpected instabilities. It would be as if two different melodies were superimposed, creating dissonances in the magnetic symphony of our star. Another variant would be to think of exotic particles. If the comet contains materials unknown to us, could they release particles that interact differently with solar radiation? Perhaps we have not detected these interactions yet because we have never seen them up close. In this sense, the comet would be a kind of natural experiment, a body that carries with it substances that, upon coming into contact with the Sun, produce unexpected reactions. Of course, all this is imagination, a game of possibilities, but it is a game that reminds us of how little we know about the universe. Each interstellar visitor shows us something new, and it would not be unreasonable to think that one day one of them will bring with it a phenomenon so strange that it changes our understanding of physics. In this speculative scenario, 3I Atlas would not just be a green spectacle in the sky, but the trigger for a more agitated sun, for a solar cycle that breaks expectations. And although we know that the most probable scientific explanation is another, the narrative of this link has its own power. It makes us look at the sky with renewed wonder, as our ancestors did, knowing that everything that happens up there can, in some way, resonate in our daily lives. Because in the end, the question is not whether a comet can alter the Sun. The question is why we feel the need to connect both phenomena. Perhaps the answer lies in our human nature. We do not tolerate chance. We look for patterns. We want stories. And September 2025 gave us a perfect story. a green interstellar comet, and a restless sun, sharing the stage as if the universe wanted to remind us that it still holds mysteries impossible to ignore. We have said that a comet like 3I Atlas cannot, by itself, alter the activity of the sun. However, in this block, we will dwell on an even more daring idea. What if the solar anomalies, those pulses of energy and unexpected storms, were related in some way to the arrival of interstellar objects? Not necessarily as a direct cause, but as part of a broader phenomenon, a kind of cosmic synchrony that we still do not understand. Imagine the following. The interstellar objects that reach our system, first Oumuamua, then Borisov, now 3I Atlas, are not just wandering fragments, but messengers from turbulent regions of the galaxy, regions where stars are born and die violently, releasing waves of radiation, shock waves, and magnetic fields that propagate for millions of years. Those fragments, ejected from distant systems, could bring with them traces of that turbulence, and although they are small, perhaps they function as seeds or catalysts that, upon entering our environment, find resonance with the natural cycles of the sun. It could be, for example, that the interstellar objects drag invisible clouds of dust and plasma. That material, upon interacting with the solar wind, would produce variations in its intensity, which in turn would alter the conditions of the heliosphere. And if the heliosphere changes, the sun could also show different responses, amplifying phenomena that were already underway. It would not be a linear relationship, but a complex echo between the visitor and our star. Another speculative possibility is that there is a statistical correspondence that we have not yet recognized. Perhaps the periods of greatest solar activity coincide with times when the solar system passes through regions of the galaxy that are denser in dust and interstellar fragments. In that case, it would not be that the comet influences the sun, but that both phenomena, the increase in activity and the arrival of visitors, are consequences of the same galactic environment. We, by observing them together, feel that they are connected, when in reality, both respond to a larger common cause, the dynamic structure of the Milky Way. From a narrative point of view, this idea is powerful. It invites us to see the universe as a fabric in which nothing happens in isolation. The sun does not beat in an absolute vacuum. It beats within a living galaxy, crossed by currents, waves, and invisible flows. And every object that enters our system is a clue to that greater movement. Perhaps, then, the solar anomalies are not simple internal whims, but responses to an environment that is constantly changing on scales that we are just beginning to perceive. Human history is full of attempts to connect the sky with life on Earth. Our ancestors saw eclipses, comets, and star showers as signs that something big was about to happen. Today, although we have telescopes and mathematical models, we still feel that need to find links. In the case of 3I Atlas, the coincidence with a more restless sun is too tempting not to imagine that they are connected. What if they were? Perhaps we would have to rethink the way we understand the solar cycles. Perhaps they are not purely internal phenomena, but also receive external influences, tiny but cumulative. The arrival of interstellar dust, of relict magnetic fields, of fragments that travel for millions of years, could have a role that we do not yet recognize. In this scenario, the interstellar objects would be like loose notes in a cosmic symphony, which when played at the right moment, slightly change the melody of the sun. They do not alter its essence, but they add unexpected nuances. And we, who are just beginning to listen carefully, confuse those notes with anomalies. Of course, this is just a conjecture, an exercise of imagination. Current science has no proof that such a relationship exists, but speculating about it reminds us that the universe is more complex than we think, and that each new interstellar visitor could teach us something we had not considered. Perhaps, in decades, when we have recorded the passage of more interstellar objects, we will discover patterns that today seem impossible to us. Perhaps then we can say, every time the solar system receives a visitor from another star, the sun responds in some subtle way. And that would be a transformative revelation, because it would show us that we do not live in a closed system, but in one that breathes to the rhythm of the entire galaxy. For now, the only thing we can do is watch carefully, observe Comet 3I Atlas on its journey, record the solar anomalies, and keep an open mind. Because in science, even the most daring speculations can be the seeds of future discoveries. And if in the end it turns out that there is no connection, it doesn't matter either. The valuable thing is that the coincidence forced us to think, to imagine, to wonder what would happen if there were. And that ability to ask ourselves questions, to not be satisfied with the obvious, is what allows us to advance. Ultimately, this speculative scenario is not just a hypothesis about the sun and comets. It is a metaphor for our relationship with the cosmos. We look for links because we feel that everything is connected, even if we do not yet know how. And maybe, one day, we will discover that we were right. Each interstellar visitor we have received so far has been a surprise. First was Oumuamua in 2017, then Borisov in 2019, and now 3I Atlas in 2025. 3 objects in less than a decade, each with its own character, each forcing us to rethink what we thought we knew about the travelers that cross between the stars. Oumuamua was the first, and like any pioneer, it arrived shrouded in mystery. At first glance, it looked like an asteroid. It showed no visible coma or gas tails, typical characteristics of comets. But its hyperbolic trajectory made it clear that it came from outside the solar system. What baffled everyone was its shape and its behavior. The calculations indicated that it was extremely elongated, perhaps 10 times longer than it was wide. Although other interpretations described it as more like a flattened sheet. In addition, it showed a slight but real acceleration that could not be explained by the sun's gravity alone. Some suggested that it was due to subtle outgassing, although no clear traces of cometary activity were ever observed. This uncertainty gave rise to more daring theories, from a fragment of a shattered world to a designed interstellar ship. What is certain is that Oumuamua showed us that visitors may not look anything like what we know. Borisov, on the other hand, was easier to classify. Discovered in 2019 by the amateur astronomer Gennady Borisov, this object did show the typical behavior of a comet: coma, tails, evident sublimation. And yet, its composition was not entirely normal. The spectra revealed an abundance of carbon monoxide much greater than that of most of the comets in our solar system. That indicated that it had formed in an extremely cold region, perhaps more distant than the confines of our Oort cloud. In other words, Borisov looked like a classic comet, but with an alien chemical stamp, typical of another star system. Now comes 3I Atlas, and with it, a new lesson. Unlike Oumuamua, which showed no tails, and Borisov, which showed an exotic but recognizable composition, this visitor has decided to shine with an intense green that baffles everyone. It is as if each interstellar object brought a different challenge. One forced us to rethink shapes, another compositions, and now this one confronts us with the mystery of color. By comparing them, we see an interesting pattern. None of the 3 behave in a totally predictable way. None of them fit entirely into our categories, and yet each one contributes a piece to the puzzle of what the debris that travels between stars is like. Oumuamua showed that solid fragments can exist, without evident cometary activity. Borisov taught us that chemistry can vary extremely. 3-Eye Atlas reminds us that even the known, like the green glow, can acquire surprising nuances in an interstellar object. It is possible that in a few years, when we have more cases, we will be able to classify these visitors into families. Those that are like asteroids, those that are like classic comets, those that show intermediate behaviors. But for now, each one remains a unique, unrepeatable specimen, which leaves us with more questions than answers. From a human perspective, this sequence of discoveries also has something poetic about it. For centuries, humanity dreamed of the idea of objects coming from other stars. It was a concept reserved for science fiction, and suddenly, in less than a decade, we have seen 3 pass by, each one different, each one reminding us that the galaxy is full of fragments traveling between worlds. We are no longer talking about abstract hypotheses. We are talking about observed, photographed, analyzed realities. The comparison also allows us to reflect on the diversity of the cosmos. Our solar system seemed to us a good model of how minor bodies form and behave. But Oumuamua, Borisov, and 3-Eye Atlas show us that this is just one variant among many. That in other places, the initial conditions produce objects with very different shapes, compositions, and behaviors, and that these objects, sooner or later, cross our path, giving us a fleeting glimpse of worlds that would otherwise be inaccessible. Some scientists have suggested that over time, these visitors could help us to better understand not only how star systems form, but also how the materials necessary for life are distributed in the galaxy. If an interstellar comet brings with it complex organic molecules, as some believe possible, that would reinforce the idea that the chemistry of life is dispersed throughout the universe. Borisov already gave us a clue with its abundant carbon monoxide. 3-Eye/Atlas, with its intense green, could be another clue in that direction. Imagine, for a moment, that in the future, we manage to send fast probes capable of intercepting one of these objects. We could directly analyze its nucleus, collect samples, bring to birth fragments of a world formed under another star. It would be like receiving a physical message from the cosmos, a tangible sample that we are not isolated, but connected to an infinite network of star systems. Meanwhile, we have the comparison, and in that comparison we discover that each interstellar visitor is a mirror of our ignorance and, at the same time, a window to the unknown. Oumuamua showed us that we do not fully understand the dynamics of solid fragments. Borisov taught us that chemistry can be radically different. 3-Eye Atlas reminds us that color, an apparently simple detail, can hide deep enigmas. Thus, each visitor is a chapter in a story that is just beginning, a story in which the galaxy reveals itself as an ocean of wandering debris, and we, from this small planet, are the fortunate witnesses of its passage. When we talk about interstellar objects like 3-Eye Atlas, we tend to focus on the technical data, its trajectory, its brightness, its composition. But beyond the figures and the spectra, there is a philosophical background that we cannot ignore. What does it mean for us as a species to receive visitors from other stars? First of all, it means a reminder that we are not isolated. For centuries, humanity imagined itself as the center of the universe. Little by little, with Copernicus, Galileo, Newton, and so many others, we understood that we are just a planet orbiting a common star. However, that feeling of isolation never completely disappeared. We knew that the stars were out there, but the distance seemed infinite, impossible to cross. Now, with objects like Oumuamua, Borisov, and 3-Eye Atlas, the universe tells us something different. Fragments of those distant worlds reach us. We do not have to travel to them. They come here. This realization changes our perspective. Suddenly, the galaxy ceases to be a distant and abstract stage and becomes a tangible, connected place. It is as if a letter written millions of years ago in another star system had crossed space to fall, by chance, into our cosmic mailbox. The question is, will we know how to read what that letter tells us? It also means humility, because each visitor reminds us of how little we know. We thought we knew how comets behave, and then one appears with an inexplicable shape like Oumuamua. We thought we understood cometary chemistry, and Borisov arrives with its excess of carbon monoxide. And now, Three-Eyed Atlas shows us an intense green that does not quite fit into our categories. Each of them is a lesson in modesty. The universe does not fit into our formulas. There will always be exceptions. There will always be mysteries. But not everything is bewilderment. These visitors also offer us hope. If fragments of other star systems can reach here, it means that the galaxy is interconnected, that there are no insurmountable walls, but invisible bridges through which debris, dust, and molecules travel. And if that debris contains organic compounds, as some researchers suspect, then life itself could be part of that network, dispersing like seeds in an infinite field. Perhaps we are not alone, not only because there are other forms of life on distant planets, but because the ingredients of life circulate freely, traveling from star to star. From a cultural point of view, comets have always aroused intense emotions. In antiquity, they were seen as omens, announcements of changes, of wars, of catastrophes. Today, we know that they have no will or intention, but that symbolic charge does not disappear. When we see an interstellar comet, we feel, deep down, that we are being visited, that something from outside comes to touch us, even if only for an instant. And that feeling is powerful. It reminds us that we are part of a story larger than the human one, a story written in the dust and ice of the cosmos. Receiving visitors from other stars also invites us to think about the future. If a fragment of rock and ice can cross the interstellar abyss, why couldn't we do it one day? Perhaps in millennia, humanity will manage to send its own probes to the nearby stars, or with even fragments of our Earth that will wander through the galaxy like seeds of a cosmic tree. In a way, interstellar comets are messengers and models. They show us that travels between stars are not impossible, just slow and patient. On the most intimate level, these visitors force us to look inward. What do we feel when we know that a piece of another star system is passing through our sky? Awe? Fear? Indifference? The answer says a lot about our relationship with the universe. Some see it as a beautiful spectacle, others as a scientific enigma, others as an omen. But in all cases, what it provokes is attention. For an instant, we lift our eyes from the ground and look up, and that gesture, so simple, connects us with the best of our human condition, curiosity. Because in the end, receiving visitors from other stars means this: that we are still capable of marveling, that there are still mysteries that shake us, that force us to get out of the routine and remember that we live in a vast, mysterious, and surprise-filled universe. Perhaps, centuries from now, people will no longer remember the technical details of 3I/Atlas. They will not know how many kilometers its nucleus measured or at what speed it passed through the solar system. But perhaps they will remember that, in the year 2025, a green comet from another star lit up the sky, and that for a few weeks, humanity united in the contemplation of something greater than itself. And that, in the end, is the most important thing. The data is valuable, but the stories are what endure. 3I Atlas is, above all, a story, that of a traveler who crossed the galaxy and reminded us that we are not alone, that we are part of a living and changing cosmos, a story that speaks to us of humility, of hope, and of wonder. In this whole story, we have spoken of Comet 3I Atlas as the protagonist, but there is another actor in this story. Us. Humanity, with its telescopes, its questions, and its capacity for wonder, is what gives meaning to these visitors. Without our gaze, an interstellar comet would be just a fragment of rock and ice passing silently through the void. It is our observation that turns it into a mystery, a story, a symbol. The role of humanity as an observer is not minor. For millennia, looking at the sky has been one of our first forms of knowledge. Before we invented writing, we were already following the cycles of the moon. Before we had telescopes, we were already associating comets with changes in history. And today, with satellites and supercomputers, we continue to do the same thing, look up and wonder what we see means. The fascinating thing is how we have evolved in that observation. Our ancestors looked with the naked eye and filled the void with myths. We look with instruments and fill the void with data. But deep down, the emotion is the same, a mixture of wonder and smallness before a cosmos that surpasses us. Comet 3I Atlas, with its intense green and its interstellar origin, awakens in us the same fascination that the ancients felt when they saw a comet cross the sky. Only now, instead of seeing it as an omen, we see it as an opportunity to learn. Our role as observers also has a collective component. No single human being could follow the trail of 3I Atlas from beginning to end. But together, with observatories all over the world, with amateur astronomers pointing their cameras from their backyards, we manage to build a complete picture. Every report, every photograph, every recorded spectrum becomes a fragment of a global mosaic. In that sense, the observation of a comet is not just science, it is a community work, a shared effort that transcends borders. This collectivity is one of the great achievements of our species. While on Earth we continue to face divisions, conflicts, and differences, in the sky we find common ground. No one can appropriate an interstellar comet. No one can claim it as their own. It belongs to everyone, and everyone can observe it. That simple truth unites us, even if only for an instant, in the contemplation of something greater. There is also a philosophical nuance in our role as observers. To look at the comet is to look at ourselves, because by observing it, we realize how fragile and fleeting our existence is in the face of cosmic scales. 3I Atlas traveled millions of years through space before arriving here, and in a few decades, it will have disappeared forever. Our life, in comparison, is a blink of an eye. But in that blink, we have the ability to understand, to record, to leave a record. And that ability, that spark of consciousness, is what distinguishes us. It could be said that comets remind us of our double nature. On the one hand, we are insignificant in the face of the vastness of the cosmos. On the other, we are immense in our capacity to give it meaning. 3I Atlas is a fragment of ice and rock, yes, but for us is a visitor, a mystery, a mirror of the unknown. That transformation only happens because we observe it. Our role as observers also implies responsibility. What we learn from this comet is not just for us, but for future generations. Every record, every piece of data, every image we save will be part of a cosmic archive that others can consult. Thus, the comet will not disappear completely. It will live on in the collective memory of humanity, transmitted in books, images, and stories. We are the guardians of that memory, the chroniclers of an event that happens only once in history. In addition, the observation of interstellar comets prepares us for something bigger, because one day, Perhaps we will receive not just fragments from other systems, but more complex signals, perhaps even of life. If that happens, our experience with objects like 3I Atlas will be a training, a way of learning to observe the unexpected with rigor and humility. In a way, we can see ourselves as cosmic sentinels. We are the eyes of the universe on itself, capable of reflecting on what happens in its corners. 3I Atlas does not know that we are watching it. It is not aware of its green spectacle or our questions, but we do know that it is there, and by knowing it, we turn it into something more than a wandering piece. We turn it into history. That is, perhaps the greatest gift of our ability to observe, to transform the ephemeral into the eternal. A comet passes and goes, but the trace it leaves in our memory, in our culture, and in our science remains. Thus, although 3I Atlas disappears into the darkness, it will remain alive in our narratives, in our archives, in our memories. In conclusion, the role of humanity as an observer is central to this story. We are not passive actors. We are the narrators of a cosmic story. We are the ones who turn a natural phenomenon into an event with meaning. And in that act of observing, of recording, and of remembering, we affirm the best of our human condition, the ability to marvel at the universe and to share that wonder with others. September of 2025 will be engraved in the memory of astronomy as a month in which the sky became unusually crowded. Asteroids, smaller fragments, and local comets appeared in our firmament, but among all of them stood out an unrepeatable traveler, Comet 3I Atlas. Its unexpected brightness, its intense green tone, and the sense of mystery that surrounds it made it the absolute protagonist of our collective gaze. Now, as its journey continues and it approaches its closest encounter with the sun, we observe it with the mixture of expectation and fragility that the cosmos always provokes in us. We know that it will not be here for long. Once it crosses our system, it will be lost forever in the darkness. It will not return. And perhaps that is the essence of its charm, the ephemeral. By looking at it, we understand that our life is also ephemeral. 3I Atlas traveled millions of years to spend a few weeks in our sky. We, on the other hand, live only a few decades under that sky. And yet, in this fleeting crossing, there is an encounter between its history and ours, an instant in which we stop, look up, and remember that we are part of something immense. The green of its coma is more than a chemical phenomenon. It is a symbol. It symbolizes the unknown, what does not fit, what challenges our categories. It also symbolizes the diversity of the universe, the confirmation that there are infinite ways to form worlds, comets, and stars. And it symbolizes, above all, the capacity we have to marvel at the unexpected. Some wonder if 3I Atlas holds secrets about life, if it contains molecules that could see distant worlds. Others see it as a reminder of our smallness. For others, it is simply a beautiful spectacle in the firmament. All these interpretations are valid because they all reflect something essential. When we look up at the sky, we also find ourselves. This comet, like those that preceded it, will become a memory. Just as Oumuamua left questions about its impossible shape, or Borisov about its strange composition, 3I Atlas will leave the memory of a green glow that no one could fully explain. And perhaps that is the final lesson. We do not always need definitive answers. Sometimes, the mystery is in itself a gift, because science lives on questions. And each interstellar visitor is an invitation to ask new questions. To expand the limits of our knowledge, 3I Atlas asked us, why so green? Why so bright? What does it bring with it from another star? And although we may never have complete answers, those questions drive us to keep looking, to keep exploring, to keep dreaming. The night sky has always been a mirror of our imagination. In it we have seen gods, heroes, omens, and signs. Today, instead of gods, we see physical processes, but the emotion is the same. When a green comet crosses the firmament, we feel that the universe is speaking to us. And although its language is enigmatic, we listen to it with attention. In the future, perhaps other interstellar objects will visit us. Some will be as disconcerting as Oumuamua, others as clear as Borisov, others as intense as 3I/Atlas, and each one will leave a different mark on us. But this moment, this unrepeatable month in which the sky was tinged with green, will remain as a special chapter in our relationship with the cosmos. September of 2025 will go down in history as the month in which the sky reminded us that we are not alone, that we are not an island, but a node in an infinite network of worlds, fragments, and stars, and that although our life is brief, we can be witnesses to something eternal. The comet will move away. Its brightness will diminish. Its tails will vanish into the void. And we will continue with our routine, with the days and nights that seem the same. But every time we remember having seen a green interstellar comet, something inside us will light up. The certainty that we were part of a cosmic instant, that we witnessed the passage of a traveler from another sun. And in the end, that is the true greatness of this event, that it connects us with the immensity, that it reminds us of our smallness and at the same time our capacity for wonder. Because although the universe is cold and indifferent, we fill it with meaning by observing it, by narrating it, by sharing it. Thus this story closes, not with definitive answers, but with an echo of questions that will remain floating in the memory, not with the certainty of the explained, but with the beauty of the inexplicable. 3I Atlas turns green, shines brighter than expected, and no one knows why. Perhaps we will never know, but in the meantime, we keep looking, we keep dreaming, we keep being human under a sky full of mysteries.